Slowly, we've been building the skills we need in order to name chemical compounds and write their formulas for chemistry. We started with simple Category 1 compounds, then Category 2, and Category 3 compounds. And then we added the polyatomic ions for Categories 1 and 2, and now it's time to add the very last step. This kind of compound is called an acid, and it has its own special set of rules, just like the other categories. Acids include any substance that starts with H. So anytime we see a formula that has an H at the front, we know we're working with an acid. Acids always have the form HX. The H stands for hydrogen, acting like a metal here. That's why it's blue. It's behaving like a blue element this time. And the X stands for the nonmetal, or the polyatomic ion that is bonded to the H. So that could include compounds like this, or these, or even this. Yes, H2O, even water is an acid. Acids are very common in nature. In fact, your body is an acid. Even though sometimes we think of acids as being very dangerous substances, the truth is that they are all around us, and they're not so bad. So let's check out these special rules we have to use for working with acids. First, if we know the formula of an acid and we're trying to give it a name, we need to start by naming it according to Category 1 rules we already know. Then we drop the hydrogen, because hydrogen should always be the first part of that Category 1 name, and then change the name of what's left according to a special pattern that is only used for acids. Let's figure out exactly what I mean by all of this. When we start changing names of elements or polyatomic ions for these new acids, we only change part of the name. The part that doesn't change is called the root. Here's a list of common nonmetals we'll be using and what their roots are. Most of these should seem familiar. Chlor for chlorine, fluor for fluorine, and brom for bromine. Nitrogens is also pretty simple, but notice that sulfur, phosphorus, and carbon have longer roots. These get to keep most of their original names, so for these elements, we'll just be adding to the end or the beginning of their names rather than changing them too much. This will become more clear when we practice. The most important thing to remember is this special pattern we use for naming acids. It goes like this: ate to ick, ite to us, ide to hydro-ick. Again, that's ate to ick, ite to us, ide to hydro-ick. This pattern is how we determine the names of the acids we'll be working with. We take whatever their original ending is and change it based on this pattern. So any name that ends with ate will now end with ick. And any name that originally ends with ide will now change so that it starts with hydro and ends with ick. Let's see how this actually works. Here's an example: HCl. This is a very common acid, and we'll use it in labs and practice problems all semester long. We start by writing its name according to Category 1. That would give us hydrogen chloride. Step 2 says to drop hydrogen, so we're left with just the chloride. Now the special part. We need to figure out the root and the ending and change it according to that pattern. Ate to ick, ite to us, ide to hydro-ick. Well, we saw before the root for chlorine is chlor. The rest is just the ending. Chloride ends with ide, so we need to use the ide to hydro-ick part of that pattern, which means chloride now becomes hydrochloric acid. Based on our steps for naming acids, our final name for HCl is hydrochloric acid. Let's try another example to make sure we're clear. Here's HNO3. Step 1 says to write the Category 1 name, which would be hydrogen nitrate. Then we drop hydrogen, which leaves us just the nitrate. Now we have to use the pattern. Nitrate's root is NITR, and it ends with 8, so we need to use the ate to ick part of the pattern to write its name. That gives us nitric acid. Everything we're doing here is based on that simple pattern. If you know the pattern, the rest will come easily. Ate to ick, ite to us, ide to hydro-ick. Here are 3 examples to try. Write the names of each of these formulas. Here are the answers. And here's some extra information to help you understand how you can find those names. We won't always be given an acid's formula. Sometimes we'll know its name. When we have an acid's name, it's even easier to recognize that it's an acid because it says acid. So now all we need are the steps for turning that name into a formula. It's pretty much just like other category 1 compounds. We just have to start by determining what the acid name is telling us. We start by using the pattern to determine what the original category 1 name of the acid was. This will tell us what the original non-metal or polyatomic ion name was. Then we use that information to write the symbols, and finally we check our charges to make sure they equal out. Here's an example to follow along with: carbonic acid. Step 1, well, since this is an acid, we know hydrogen is acting as the metal. And the root carbon tells us we're using some version of carbon, either just the individual element or a polyatomic ion that has carbon in it. The ending "ic" is important. According to our pattern, which says 8 to ic, the ic had to come from something that originally ended in 8. So this must have originally been carbonate. So hydrogen carbonate is the original category 1 name for this acid. Now we need to write the symbols and finish our formula. Hydrogen gives us H, and carbonate gives us CO3. When we look at the charges, we get +1 for hydrogen and -2 for carbonate. That's from the polyatomic ion list. We can plug those numbers into AX plus BY to determine our subscripts. The charge on hydrogen is +1, so X equals 1, and the charge on carbonate is -2, so Y equals -2. The LCM of 1 and 2 is 2, so A must equal 2, and B must equal 1. That means our subscript for hydrogen is 2, and our subscript for carbonate is 1. Watch out for the family. Use parentheses if it helps to protect the babies. So our final formula for carbonic acid is H2CO3. The trickiest part of working with acids is recognizing them. Once you know how to follow your acid rules, it's as easy as 8 to ic, ike to us, ide to hydroic. Here are 3 more examples to practice with. Write the formula for each acid. Here are the answers. I'll explain each of these quickly. The hydroic in hydrobromic acid tells us that this was originally bromide, so H plus 1 and bromine minus 1 come together to form HBr. The ic ending here tells us that this used to be phosphate, which is PO4 with a charge of -3. Equaling that out with hydrogen's +1 charge gives us H3PO4. Sulfurous tells us that sulfite is the base of this acid name. Sulfite is sulfate minus 1 oxygen, so sulfite is SO3, still with a -2 charge. That gives us a final formula of H2SO3.